My name is Holger Voß. I'm a full professor in automation at the University of Luxembourg since 2010 and also active in the Interdisciplinary Center for Security, Reliability and Trust. So the main research focus of my team and myself is on the automation of autonomous mobile robots and vehicles. This spans from robots on the ground, drones, up to moon rovers or satellites flying in space. So on the one side, we investigate how such autonomous vehicles can perceive the environment, the complex environment in which they are located, and how they can build mathematical models of that inside the robot and in real time. On the other side, we work on planning algorithms. That means how these robots can autonomously plan their actions and activities, and how they can also control their motions. Examples of that are autopilots for drones, navigation of moon rovers, or the formation control of satellites flying in space. So for me, one of the key achievements over the last 15 years here in Luxembourg is the fact that autonomous vehicles and robots and research on that is now considered an important and also a relevant research area here in Luxembourg. And that Luxembourg now in the meanwhile is also an active research actor, you could say, in the international robotic community. This was not at all the case when I started here in 2010 in Luxembourg, and I think with the team we considerably contributed to that by bringing excellent researchers here to Luxembourg, working on papers, working on projects and working on demonstrations. In the meanwhile, a lot has been achieved. For instance, you could see that in 2020 also the FNR included autonomous vehicles and robots into the list of the national research priorities. And on the other side, if I currently look at my PhDs, which are graduating, a lot of them are currently getting jobs here in the local industry and still continue to work in Luxembourg on robots, which was also not the case at all when I started here 15 years ago. A second highlight for me are these many collaborative research projects that we had together here with partners in Luxembourg. Partners were industrial partners, but also the city of Luxembourg or the army of Luxembourg. And within these projects, we worked on numerous of applications of robots, for instance, using drones for the inspection of aircraft, navigation of moon rovers, formation control of satellites, also using robots for the 3D scanning on construction sites. So with the help of these applications, we were always continuously enforced to find the right balance, I would say, between our theoretical research on the one side and the practical application of this research on the other side. One area that we already work on, but that I also consider as important for the next years, is the even tighter integration of these aspects of situational awareness on the one side and planning and control on the other side in the robot. For instance, we currently work on comprehensive mathematical models, which are describing scenarios with all of its different facets. That means plans, maps of the environment, also dynamic objects which are moving, even semantic information or uncertain information. And on the other side, to directly couple that with planning and control, that the robots can act much more efficient and much faster with the help of this tight integration of perceiving and action on the other side. Another very important area where we currently start to work on is the integration, the interdisciplinary integration of different forms of intelligence in order to automate autonomous robots. So here we talk about artificial intelligence, but also biological intelligence, embodied intelligence, and also, for instance, social intelligence. For instance, if you look at a mobile robot, you can improve the behavior of the robot by implementing a machine learning approach in the robot, but you can also let the robot act more in an intelligent way by adding a more sophisticated robotic arm, for instance, a soft robotic trunk-like arm to it, which then also combines at the one side artificial intelligence, but also what we call embodied intelligence. That means the intelligent behavior comes from the body of the robot. And this interdisciplinary research will then also require a lot of collaborations also with the colleagues coming from these different domains. It's from physics, from biomedicine, but also from social science.